So thank you everyone, obviously, for being here, and thank you to the conference for having me. I'm going to be talking about continuous performance testing in DevOps, as I think maybe the only person up here that's dedicated to testing. I congratulate you. Testing is still part of DevOps. I'm going to skip the bio, but only talk about the fact that I've been doing this for long enough that I've realized that the way we've been doing performance testing for so long has one serious flaw. And that flaw has brought me to declare that performance testing is dead. And for any of you budding performance test engineers out there, don't run for a cliff to jump off of just yet. Let me qualify that and say that traditional performance testing is dead, and we'll talk about that in a second. Do I really believe that? No, and I think if I blow up the fine print there and say that traditional performance testing is the only evaluation of a system's performance is dead, or in my opinion at least should be. Let's talk a little bit about first what traditional performance testing is. Certainly born out of the waterfall model, where we had releases that went on for many months, and near the end of that release we would execute a performance test that typically lasted many weeks. And along with that process, we had some very rigid rules. Rules that said if the application isn't functional, at least in a single user mode, how can you expect me to test it under some type of load? You better freeze your code while I'm doing my scripting and my execution, otherwise I'm going to have some rework to do. And oh, by the way, if you want your results to mean anything, you need to give me a production-like environment. And as ridiculous as maybe that sounds today, we did this for many, many years. We spun up a lot of large centers of excellence around performance testing. And we thought we were doing everyone a great service. And by all measures, we were successful. But that brings me back to that flaw. What if we find issues? After months and months and months of development, what if we find issues? Our options aren't good, right? We either delay delivering the value to our customers that we're trying to build in the first place, or we get hit by what I call the freight train. And the freight train's lost revenue, lost brand value, lost customer loyalty, and probably a dozen other things that we attribute value to that can be impacted by poor performance. So our options aren't good. So there must be a better way. And going back when we first made this realization, probably 8-10 years ago now, we first thought that the answer was, well, let's take that traditional performance test process and compress it so we can somehow do it within delivery sprints, or at least at the end of each delivery sprint. But the problem was we had short, agile delivery cycles, and we had very rigid, lengthy performance tests still, even with our efforts to compress it, and that was a recipe for disaster. So what we were searching for is some way to get a more continuous performance test, a continuum of performance test data. So what the rest of this talk is really is a case study of a 2-year-plus journey that we took with an organization going back about 8 or 10 years on how we transformed from a large centralized performance testing function to something that was more continuous and executed by the delivery teams themselves. Let's first take a look at what continuous performance testing is, and I think maybe it's best to first talk about what it isn't. As we just talked about, it's not more frequent traditional performance tests. It's not moving the traditional performance test earlier in the delivery cycle. And it's not even just faster or completely automated performance tests, although certainly earlier, faster, and automated is a big part of that. But what it is an appropriate evaluation of performance at each stage in the delivery cycle. It's more frequent, more visible feedback, and it's trending that performance results across builds. Again, so we have a continuum of data to look at. But even as I talk about this today, 8-10 years later, there's not a lot of organizations, if they're doing performance testing, that are doing anything besides traditional performance testing. I think there's a lot of reasons for that, but there also must be some obstacles, some things that are missing. So let's talk about those for a second. I think there's several big ones, certainly ones that we found as we went through this process. First is performance is just not part of requirements. No one's talking about performance factors early in the process. There's not a whole lot of ownership or accountability by the delivery teams, right? It was always someone else's responsibility, so they're just not used to thinking about it in that way. For similar reasons, the delivery teams lack the expertise to execute continuous performance testing. And while organizations certainly have monitoring and observability tooling in production, they very rarely are bringing that into the lower environments, although I am starting to see a trend in the right direction there. So let's talk what we can do about those obstacles quickly. If we look at performance, right, and let's take this feature here, maybe for a customer call center, the ability to search on a customer in various ways, what are the performance factors that might impact that? Maybe we know we have a peak of about 90,000 searches an hour, and maybe we need that customer information back to the agent in less than 5 seconds, because by the time they're done authenticating and greeting the client, they need to have that information available to begin their interaction. I say performance factors for a reason. One big lesson learned that we had when we started to try to elicit performance requirements very early was that either the organization hadn't thought about it much, or we got into a state of analysis paralysis where, because we didn't have all the questions answered, they were trying to just get it down to a very fine level of detail, and we're struggling with that. But when we backed off and removed some of the constraints around how those were documented and the level of detail, et cetera, we did start to get much more information that we could now start to build awareness around performance much, much earlier in the delivery cycle. But of course, at some point, we need to document those requirements a little bit more formally. And I found there's a handful of ways. The one we settled on in this case was primarily using constraints. If you think about performance-related requirements, they often apply to many features at once, right? Maybe they all have to conform to some type of response time or support some type of concurrent load or throughput levels. So by setting up constraints and then linking acceptance criteria to those constraints, you save yourself a lot of work, both in the initial documentation as well as any maintenance that might have to happen. Of course, there's certainly some features that are going to have some specific performance acceptance criteria, and of course that's completely acceptable. The next thing we need to talk about is accountability. And I see accountability being made up of awareness and visibility. If teams aren't aware of what they're accountable to, it's really unfair to hold them accountable. And we just talked about building awareness, discussing performance requirements early, and incorporating the performance requirements more formally in our work. But we need visibility as well. And we struggled for a while in making it visible. We had a little early momentum in documenting performance requirements early in the process, but it faded. So we determined we needed some more visibility, and we found the best way to do that was to include the incorporation of performance requirements as part of the definition of done. So we tried the carrot. The carrot didn't work, so we had to bring the stick in. Next is integrating performance skills and tools into the delivery teams. Another mistake we made very early was we took all the engineers from the Performance Testing Center of Excellence and we embedded them in a good handful of teams at once and tried to transform really an entire organization. And that did not end well. It was just a poor exercise in change management. We had teams trying to solve the same problem in multiple ways, not a whole lot of communication, a lot of the processes weren't established. So we backed off and just focused on one team that we thought was most ready to go through this change, and that worked much better. And once we got that to a certain level of maturity, then we started to expand to other teams. We also created what we called a virtual center of excellence. It was nothing more than a community of practice that the teams could use to share knowledge, share practices, prevent them from reinventing the wheel. And that worked very well. Also brought the monitoring and the observability tooling into the lower environment. So in addition to just having the symptomatic level metrics that a load tool is going to provide you, we had much lower level metrics that we could use to trace those symptoms down to the root cause. So all this helped us to go from the old model where we had a centralized performance testing function that worked well for a while, but certainly did not jive with the more modern ways of developing software, to a situation where we had that embedded in the delivery teams. So let's look at a delivery pipeline, a very simple one, and talk about where we can learn performance at each stage. Certainly we can learn about performance in a performance or load environment. This is where you're going to execute something more like a traditional system-level performance test. Hopefully, though, it's not now your only evaluation of performance in your system. Definitely learn about performance in the integration environment. And when I first got started, it was absolutely taboo to think about testing in production, but now many, many organizations are doing some form of performance testing in production. And I will say, and I should have said this up front, when I talk about performance testing, I'm using that term generally to talk about multiple types of multi-user testing. I'm less concerned about what you call the type of testing you're doing, and I'm much more concerned that everyone's on the same page of why you're doing it and what it is. Otherwise, you just end up in a long religious debate sometimes about what's load versus performance versus stress, et cetera. We can even learn something about performance at the commit stage. So I'm talking about unit-level performance test. Given we have a shorter slot today, I'm going to focus on integration, user acceptance, and performance load. I have included extra slides talking about unit-level performance and production performance testing. So if anyone wants a copy of the deck, please let me know. So let's talk about performance at the integration stage. And this is where talking about component level testing. So single calls to endpoints, this is all very easy if you've got a service-based application, a little bit more complicated if not. Small, short test, some amount of concurrent load, some number of iterations. We're balancing the need for fast feedback with getting enough data to actually tell us something. Depending on how well you manage your environment, manage your data, you might want to mock out your dependencies to reduce the setup complexity. I think that's okay at this stage. I think the ideal situation, though, is that they're not mocked out. We're testing components individually, and we're measuring, again, not only those symptomatic metrics, but also lower-level application and even infrastructure metrics, so we can get the whole picture and trace those symptoms down to their root cause. There's some important considerations, right? We want to execute these, if we can, on every deployment. We learned the hard way. You probably shouldn't automatically break the build. Performance testing results just aren't as deterministic as functional results. And there's a lot of reasons why they may not be what you expected. And we learned that if you break the build unnecessarily, you lose the privilege of being part of that build. And probably the most important thing that we learned is to trend those results across builds, right? We're not in anything like a production environment, most likely. We're not putting these components under production load, most likely. So the absolute value of the results is less important. We're looking for the trend, right? Is the trend getting better? Is the trend getting worse? And it gives us the ability to trace those regressions or much more easily to the commit that caused them. Moving out to the acceptance stage. So maybe the user acceptance environment is where you're running the user acceptance test, your automated regression test. You can run some additional component tests there, maybe your less critical components, because again, we're trying to balance our need for fast feedback. We've also been doing, very much so lately, capturing performance metrics as part of our automated functional tests. It's relatively easy for most frameworks to be able to capture response times, whether it's API or UI level. And if it is UI level, we can even tap into the browser performance metrics and get some additional detail. It gives us a good baseline for what performance looks like in a single user mode. And then, of course, in the performance load environment, that's where we're executing something that looks more like a traditional system-level performance test. Some important considerations here as well. Still trying to execute these in every deployment if we can. We're probably in a more production-like environment now. I wouldn't suggest mocking out your dependencies. If you do have environment and data instability, it's probably impacting other activities in those environments as well, and I would suggest that you take care of that rather than mock out or virtualize the dependencies. And again, those, probably less frequently you're running those larger traditional performance tests in the out-of-flow performance or load environment. So I want to take a step back and just look at it from the big process and tooling level. I've got some tools here on the slide that you'll see. Absolutely not recommendations, just to give you an idea of the types of tools that I'm talking about. We have the system that we're testing. We have the environment that we're in. Of course, we need some type of load tool to generate load. Ideally, we're bringing monitoring and observability tooling into that environment, those lower environments. We need to collect the results somehow. We need to broadcast them to those that need to see them, and maybe even generate some alerts as well. One thing I want to remember, or I want to mention before I go on, back when we first started this, we were using some open source load tools, and they're just not up to par in terms of analytics, and they're getting better. But nowadays, with commercial tools, they have better analytics and data visualization capabilities, so you might get away without kind of externally storing those results somewhere else. It might lock you into a tool a little bit more, but it'll save you a couple steps. And of course, before I finish up, we want this all as automated as possible. You might be saying, hey, this sounds like a lot of work, and you're right, it's not a trivial amount of work. How else can I do all this? Well, I have my backlog to deal with in the first place. But this should not be off the books work, right? And that's another big mistake we made. We worked on this kind of as we had time, and we didn't really get much momentum. And when we made it part of our technical backlog, or how you all manage your continuous improvement efforts, so we could prioritize this work along with all the other things that we had available for us to do, we started to gain some more momentum. It became more visible, and the organization as a whole was able to prioritize it appropriately. I want to talk through, before we wrap up and take some questions if you have any, discuss the implementation approach and some more of the lessons learned that we went through. Again, first, start slow and small, and then speed up and scale. When we started with a single team and focused just on component level testing, we got that to the level of maturity that we wanted. It was much easier for us to scale that to other teams, and then we went back to that first team and started to scale to different types of testing throughout the environment. And that's when we really kind of got the flywheel moving, as opposed, again, to try to boil the ocean with the entire organization at once. As I just mentioned, make this part of your technical backlog, or again, however you manage your continuous improvement efforts. You won't get it right the first time. You're going to find better ways to do things. You're going to change tools, change processes. That's okay. It's part of learning, and if you're learning and improving, that's the whole point. it will not be certainly a fire and forget solution. This is probably the biggest, next to thinking about performance requirements early, this is the biggest lessons learned we had. Avoid information overload. We came in from the Performance Testing Center of Excellence to the delivery teams, and we're very prescriptive. We were the experts. We were telling them what to do. We were throwing a bunch of data at them, and they had no idea what to do with it. And pretty soon, as you might imagine, they started ignoring it. But once we stepped back and helped them understand what we were doing, why we were doing it, what the data meant, to the point we took everything away, and then when we found issues, we would expose that issue to them, and we would walk with them through the process of investigating the issue and getting down to the root cause. And once they started to understand and learn, then we didn't have to force anything on them. Then they wanted more and more and more and more. And we learned something, right? As we went through that process, we were performance testing experts. We were not performance engineering experts. And the delivery teams, as we learned, had quite a bit of knowledge and expertise in performance engineering and how to, what the impact from a performance perspective of their work was and different approaches, et cetera. So it was a learning process for everyone. Probably the number one thing is make sure they're ready to act on it, right? If you throw a bunch of data, give them a bunch of information, and they're not ready to act on it, you're never going to get the benefit. Performance testing, as with most things, is not just tools. Although a lot of people that you'll meet will have that, I think, that philosophy. But you need to take care of the supporting factors. First of all, again, we have the need for fast feedback. So we need to think very critically about what our testing scope is. Right? We're not going to throw long, lengthy tests at every possible system component that we have. We need to understand what's critical. As you get better at this and get the processes in place, you can probably expand that scope. But at first, you want to certainly focus on your most critical testing tasks. You need your test environments and your data stability to be in a state that it can support on-demand execution of these tests. If you're not there, as I mentioned, you certainly can mock out some of the dependencies, but you're losing some things. And again, that instability in your environments and data are probably impacting other processes anyway, so there's probably a lot of benefit for you to clean that up. Talked about this a little bit when I was talking about information overload, but solicit feedback. We were in, I guess, the very arrogant position of being longtime performance testing experts in this organization, looked upon as really the only performance testing knowledge in the organization. We took that as a cue that we should be very prescriptive and lecture the teams on what they should be doing. As I mentioned, that did not work out very well, but when we started to solicit feedback on what was important to them, on did they understand what we were talking about, what else did they want to understand, we just started to gain a lot of momentum moving forward. All right, so let's wrap up here and talk about just a handful of things that if you remember nothing else from this 30 minutes, these are the key things. First of all, that traditional end-of-cycle performance test should not be the only evaluation of your system's performance, right? If you're finding out late in the game that you have performance issues, at a minimum it's going to cost you more to fix it, or you're delaying the value delivered to customers, or you roll the dice, right, and you risk getting hit by that freight train. Realize that continuous performance testing is analyzing performance as appropriate at every stage of the delivery pipeline. And that this should become part of the way the organization delivers software. Again, I've seen organizations try to implement continuous performance testing with a separate dedicated team. and kind of reach into the delivery teams and perform these tasks, it tends to be very inefficient. But when you build the skills within the delivery teams, it all becomes a lot easier. And again, start small, get feedback, and of course, it's important to continuously improve. All right, if we have a few minutes, 3-4 minutes, if there's any questions we have. Otherwise, please feel free to reach out to me at any of these methods. I'm always happy to talk about this stuff. Okay. All right. Well, thank you very much.